All right. Two events being independent, knowing whether or not one event occurs does not change the probability of the other event in any way, shape, or form. Written out as a formula using that probability notation that we learned first semester. That means the probability of event A is exactly the same as the probability of event A given B did happen. It's exactly the same as the probability of event A given that B did not happen. So A given that B given that B complement is just the probability of A. If two events are independent, there is no association, there's no relationship between those two events. I want to investigate today whether or not there's an association between taco tongue and evil eyebrow. Do you guys remember doing that first semester? We had like that two-way table. Can you taco tongue? Can you? I can't evil eyebrow. So we've got the data from a random sample of 600 senior students. That's this table right here on the left. Do we have convincing evidence that the ability to do the taco tongue and the evil eyebrow are associated? Is there a relationship? If you know somebody can do one, do you now have information telling you about the probability that they can do the other one? We want to find our expected counts exactly the same as we did yesterday. Row total times column total divided by table total. Go ahead and do that to fill in the expected. Yes, ma'am.
Total.
Yeah, this is your row total. This is your column total. So if you do this and this, you're going to find this one. So 480 times 200 divided by the table total. And then you put that number here.
Okay.
Row total times this column total will give us this one right here. So 480 times 400 divided by 600 to get this. Does that make sense?
Yes.
Okay. When we do these expected counts, we're filling this table in as if these events are unrelated. There is no relationship, there's no association. So 480 out of 600 should be able to taco tongue, or about 80% of the population, right? If 80% of the population can taco tongue, then how many in this group should be able to taco tongue? Right up here. Out of these 200 that can evil eyebrow, 160. This row total times this column total divided by 600. So we're looking at the intersecting cell there. What would be the expected expected outcome or expected value, expected count for yes taco tongue and no evil eyebrow? Yes. 320. Yes evil eyebrow and no taco tongue? 40. No taco tongue, no evil eyebrow. 80. So far, so good? We calculate the expected values for the test for independence exactly the same as we do for our test for homogeneity. Row total, column total, divided by table total. Do the data provide significant evidence that there is an association between the ability to taco tongue and evil eyebrow for all seniors? We're going to use an alpha equals 0.05. So I know the significance level, they gave me that. The hypotheses. Null hypothesis, we're going to assume there's no relationship here. So my null hypothesis would be that taco tongue and evil eyebrow are not associated for all seniors. These events are independent. What should my alternative hypothesis be then? That they are associated. Taco tongue and evil eyebrow are associated for all seniors. They are not independent, or they are dependent would be another way of phrasing that. What I have written in blue is how you should write your null and your alternative. There is no association between these two. There is an association between these two. The name of this procedure is the chi-square test for independence. Sometimes you will see it referred to as the chi-square test for association. Same exact test. It's just two names for the same thing. We have to check our conditions here. Do we get the random condition? Give me evidence. I agree that it's yes. Give me evidence. Random sample of 600. Yep. So we've got our random sample of 600 seniors. Why do we need to meet our random condition? What's our population here? All seniors. We're going to generalize to all seniors. Do we get our 10% condition? Yes, sir. Mm-hmm. Good question. So when we're talking about the 10% condition, we are trying to make sure that as I take a sample of this population, that I'm not affecting the probabilities right there. That's a really good point. We are testing to see if this event and this event are independent. But as I pull my sample, I want to make sure that I haven't drastically changed the overall population proportions. Sorry. As long as there are 6,000 seniors, which they didn't say that we were looking at just one school. So if I said I'm looking at all seniors in the state, all seniors in the US, we're going to assume that we have our 10% condition met. And this means that sampling without replacement is going to be okay. It's not going to affect my overall population distribution. Do we have our large counts? What do I need as far as large counts go for a chi-square test? For any of my chi-square tests, all expected counts are greater than 5. Do we have that? Yes. I need to provide some type of evidence for that. So in parentheses, I've got C table. I made that table that has all my expected counts in it. As long as you show that somewhere on there, you have shown evidence that all your expected counts are greater than 5. All of our chi-square tests, we need expected counts greater than 5. Why do we need expected counts greater than 5. Yes. So that our distribution is approximately chi-square. All right, let's do this. You can use the lists in your calculator. You only need to set up how many proportions for this one? 4. So you could write them, like you have to write down at least 3. You have to show the first 2. You got to do the last one. You might as well write down all 4 on this one. Our specific formula here, chi-square is equal to the summation of observed minus expected squared divided by expected. Go ahead and work through that. And give me a quick thumbs up once you actually have that chi-square, the test statistic, calculated. Anybody have a chi-square yet? 18.75. So I'm curious about something here. Each of these, when I do the observed minus expected, it's either 20 more than expected or 20 less than expected. Like all of these are off by 20, right? From the expected. They're all off by 20, but which one is making the biggest impact on that chi-square score? 20 minus 40. 20 minus 40 corresponds to what on the table? Like looking at like taco tongue, evil eyebrow. What'd you say? No taco tongue, yes, evil eyebrow. That one proportionally was much farther than expected, right? All right, so our test statistic is 18.75. Does anybody remember how to calculate degrees of freedom when we're looking at a two-way table? Rows minus 1 times columns minus 1. How many rows did we have? 2. How many columns did we have? 2. If I take 1 away from each of those, I have 1 times 1. So we have 1 degree of freedom. So there's what my chi-square picture looks like. I don't know if I got the 18.75 in exactly the right spot, but I know it's to the right of that big bump. If you haven't already, please go ahead and calculate that p-value. So we're going to use chi-square CDF. Without telling me your p-value, are we going to reject or fail to reject? Reject. You should have gotten a p-value of like 0.000149115, or that would be like 1.5 times 10 to the negative fifth. How do I interpret this p-value here? Yes, sir. Assuming the null is true, what was our null? Taco tongue and evil eyebrow do not have an association for all seniors. There's a p-value probability. Absolutely. So interpreting our p-value, assuming the null is true, there's no association, these events are independent. There is a really small probability of getting a chi-square of 18.75 or greater purely by chance. That purely by chance on the end is really important. If you don't include that, that does affect the overall quality of your answer. So our decision, our conclusion is to reject, and that means we have convincing evidence for our alternative hypothesis. Because our p-value is less than our significance level, 0.05, we reject the null. We've got convincing evidence of an association, a relationship between taco tongue and evil eyebrow for all seniors. Yes, sir. We do need our little follow-up here. Why do we need a follow-up on this one? Because we're rejecting the null. So what would my follow-up be? Yes, sir.
You said there were more people expected to be able to do more. Yes, people were eyebrow and
So, yes, you want to be really careful in how you state that. Number of no taco tongue, yes, evil eyebrow was, and then I have to look at this here. When I do this subtraction, yeah, my observed was way less than my expected. The number of no taco tongue, yes, evil eyebrow was far lower than expected when I look at this proportionally. So the largest component of my chi-square score is coming from no taco tongue, yes, evil eyebrow. So far, so good? All right. Big idea time. In our chi-square test for independence, or you can call it a chi-square test for association, means the same thing. Your null hypothesis is always that there is not an association between my two categorical variables. My alternative hypothesis is that there is an association between these two. That's really the only thing that's different from today and yesterday. We've talked about 3 different chi-square tests this week, though. If I have one sample and I'm looking at only one variable, like when we did the M&Ms and we were looking at color, that's a chi-square goodness of fit. If I have 2 or more samples, but I'm only looking at one variable, like when we did the gummy bears. We looked at Haribo, we looked at Meyer, we could have looked at Albanese as well, but the only variable we were looking at there was color. That's our chi-square test for homogeneity. If I have a single sample, like the 600 seniors here, but I'm looking at 2 different variables for those seniors. Can you taco tongue? Yes or no? Can you evil eyebrow? Yes or no? 2 variables. That's our chi-square test for independence. Copy that down. And then in the check your understanding, this should be a pretty fast one today. I want you guys to determine which test for these different given scenarios. Would we be looking at the chi-square test for independence, chi-square test for homogeneity, or chi-square test for goodness of fit? What do you think on the first one there? Chi-square test for independence. We have how many samples? One sample. How many variables? 2. What are those variables? Yep, types of PISA and class year, types of PISA and grade level. It also gave me a hint at the end here. It said the school would like to know if there is a relationship between these things. 1 sample, 2 variables, chi-square test for independence or association. What about the second one? Yes, sir. Chi-square test for homogeneity. Why?
Because the random sample of freshmen and sophomore and seniors, that's more than 2.
That's more than 2. We got 4 random samples here. But we are looking at 1 variable. In this case, the school wants to know if the distribution of opinion differs from grade level to grade level. So we want to know, is it the same distribution between freshmen and sophomores? Is it the same distribution between sophomores and seniors? So chi-square test for homogeneity. What about the last one? Goodness of fit. How many samples do we have in the last one? Just 1 sample. We're looking at just 1 variable, and I want to know if that distribution matches a known distribution. Not does it match some other one that I also have a sample for. Does it match what I know it was beforehand? Chi-square test for goodness of fit. All right. So, question. Does anybody here like true crime? Yes. All right. So the paper that I passed out to you guys, the single sheet, not the stapled one. The stapled one is your test review. Have you guys ever heard of a person named Kristen Gilbert? Kristen Gilbert was a nurse who worked in the Boston area. She worked at the VMAC, the Veterans Affairs Medical Center near Boston. I don't know exactly where in Massachusetts she was. She started there in 1989. And she was described as highly skillful, calm, compassionate. Overall, she was a good nurse. She organized charity drives. One of her defense attorneys said she once organized a memorial service for a colleague who died of cancer. She had this odd tendency to be working shifts when patients died. So much so that her coworkers nicknamed her the Angel of Death. This raised suspicions. Federal prosecutor Bill Welch, in this case, said that the death rate seemed to increase significantly during the shifts that Gilbert was assigned to. In particular, her coworkers started to raise concerns about an increase in medical emergencies. Patients coding, so specifically heart issues were happening. They noticed this big rise between August of 95 and February of 96. And so a criminal investigation was launched. shortly after the criminal investigation was launched, Gilbert left her job when she learned that she was the target of this investigation. According to a search warrant affidavit, a statistical analysis of codes, this all came straight from the Boston Globe news article. A statistical analysis of codes and deaths in Ward C between January 1, 95 and February 19, 96 showed that Gilbert was present or on duty for 37 of those deaths. Authorities determined that the likelihood of her frequent presence during these emergencies was that it was merely coincidental was, and then I've redacted this last piece. So, what I've read so far sounds highly suspicious, right? I don't know exactly how big this hospital is. 37 deaths over more than a year. Is that enough to, I mean, obviously the hospital felt like that was enough to raise suspicions. What do you guys think?
I think it's possible.
Possible.
There was another hospital serial killer operating at the same time.
What other explanations could there be for why Gilbert had more deaths on her shift? What'd you say?
She's had a higher work rate because she knows.
Sorry, I still can't hear you. My apologies.
She had a higher work rate because she wasn't her coworkers.
Higher work rate compared to her coworkers. Maybe she was working more hours than the other nurses.
Someone's framing.
Someone's framing her. Anything else?
Just a bad nurse.
She could just be a bad nurse. Appears good at her job, but isn't actually. Could being bad at her job, like, could she still be held criminally liable if she was bad at her job? Yeah. Do you think it would matter which shifts she was working?
Because if the patients have been in the hospital for longer and if they're under critical condition, there's a likelier chance that the longer that there's
Yeah, and like length of patient stay might be a contributing factor. Not sure. Day shift, night shift? Would that maybe? I don't know, I'm just thinking of like all the other possible variables, because we've got confounding variables that we've talked about. You gotta be really careful when you start accusing somebody of murder. Because what's the presumption here in the US? Innocent until proven guilty. You bring charges against somebody, it's still presumed that they're innocent. The prosecution has a really hard task. They have to show that this person is not innocent. What information would you need from me, or from the Boston Globe, or from this investigation, if I was going to ask you guys to come up with a decision?
The population of the ward.
Population of the ward? Good question, yeah, like what significance level are we using? What else would we need? Yes?
How many patients like go into a code during the same time usually? Time, months?
Yeah. Did you have an idea, John?
I was gonna say how like codes and deaths total, like 37 out of how many of this patient?
Yeah. So I've got some of that information. I have what they used when they did this statistical analysis. And I'm going to give that to you guys. They did not look at every piece of data because they're looking at a year and a month. How many 8-hour shifts are there in a year and a month? A lot. A lot. Do they have the time, energy, and resources to look at every single 8-hour shift? No. If they collect a large enough sample, though, and it's randomly taken, could they make a reasonable prediction or a reasonable conclusion? Right. They took a sample of 1,641 8-hour shifts. randomly selected from this year and a month. And they broke it down to whether Gilbert was working or not working during those shifts, and whether any deaths occurred during those shifts. What type of test would you want to use on something like this? We're going to use some type of significance test. Independence. What would we be testing for the independence of? Yeah. Is there a relationship between her working and people dying? I want you guys to start on this. Monday, we'll finish this up. But I want you guys to reach a conclusion about whether or not you believe that her being present during these deaths were coincidence, bad luck, or is it likely that she murdered you?